Let me start with a huge, heartfelt thank you to Lewis and the organizers for what they put together and for the invitation to come and really represent the broad plastics, bioplastics, and packaging industry here this morning. So thank you. What I'm going to do in the next 30 to 40 minutes is talk about innovation in packaging technology. And moreover, I think you've heard a compelling case this morning as to why when it comes to packaging, the big opportunity is plastics in packaging. So that's what I'm going to focus on, plastics. I'm going to give you an industry perspective, a little bit different from the prior speakers, an industry perspective both on what sustainable plastic packaging means and what's possible, what's real today. You've already heard good mention of the circular economy. Indeed, you've heard of the Ellen MacArthur Foundation. Ignacio did a nice job of framing this out. The Ellen MacArthur Foundation is a UK-based nonprofit that is a leading architect of the circular economy. Why they're of relevance to this discussion is they're a leading thinker in taking this abstract idea of circular economy down to something real and actionable for plastics. As Ignacio framed out at the Davos World Economic Forum earlier this year, they launched literally a blueprint for plastics, a blueprint for sustainability in plastics. And what they did is they looked at this not just from a strict one dimension of sustainability, but they looked at the business opportunity, the business case for plastics, which is why coming from the industry side, we think they've really framed this out nicely. Something else they did a nice job of is including a huge group of stakeholders. And I and some of my colleagues and broader industry colleagues sat on the industry stakeholder group. I'm pleased to see the sort of what came out of this, the pragmatic approach, the holistic approach. So making good use now of some of the slides they've made available to their stakeholders, and I'll go through this quickly because you've seen some of these statistics. This sort of gets at the magnitude of the opportunity. This is what's happened over the last 50 years, a 20-fold increase in global plastics. And for this audience today, I think what is relevant is where that's going, not just where it got to, but where it's going forward, which is expected to double again in the next 20 years and a 4-fold increase to quadruple by 2050. Now, that's global plastics. What piece of that is packaging? More than a quarter, 26%. And therein lies the opportunity for us as a plastic packaging industry. So you also heard this from the prior speakers. Plastic packaging is unfortunately, the iconic linear application, the take, make, waste model. Ignacio did a nice job of framing this out, so I'll go through this quickly because this just puts a pretty picture, courtesy of Ellen MacArthur, behind the numbers you already heard from him. That 26% of global plastics that's packaging, that equates to 78 million tons. 98% of that today is sourced from virgin raw materials, and almost completely those raw materials are absolutely reliant today on fossil resources. Where does it go? Let's follow the numbers. Far and away the biggest use, as you heard from Ignacio, 40% unfortunately goes to landfill. The second biggest outlet is what is charitably called leakage. Leakage to the natural environment, to our countryside, to our oceans. And you've seen compelling pictures of the impact of that. Some 14% is captured for energy recovery, and some 14% is collected. And I emphasize the word collected for recycle. Of that, there's a yield loss, and that leaves 10%, and these are global plastics figures, 10% that is recycled, 8% of that is recycled into uses that, I don't like the word downcycling, but what the foundation makes clear is these are uses where they will probably not be recycled again, so they will fall out of the circular economy. That leaves 2% that is truly recycled in kind. And so 2% recovered, 98% virgin. So where do we go? And what the MacArthur Foundation has done very nicely, laying out this blueprint for plastics in packaging, is defined a way to jump on and capture the opportunity you saw on that prior slide. And what we like about what they've done is they outline this as a business opportunity, which is how this change is going to get made. So now, starting at the bottom left, the ambition is that all materials, if they're virgin, are completely uncoupled from the fossil economy, that packaging would be renewably sourced, and that largely there would be a recovery loop as well as a reuse loop, that things would be made more durable for reuse. That there's also a very legitimate use for composting, for getting food waste organics, for example, out of landfill, whether it's through composting or through anaerobic degradation. So 3 big goals: uncoupling from the fossil economy, reducing leakage, and improving the business case and working business models for recovery. I'll talk more about this. Some of you may have heard of a group called the Sustainable Packaging Coalition. This is a US-based nonprofit. We were a founding member, and most of the big global brands belong to this organization. What I like about what they've done here is they put meat on the bone, so to speak, of the Ellen MacArthur's construct. And what they've shown is specifically, what does sustainability in packaging mean? We've talked very generally so far, and I want to get this down to specifics around what does it mean we do differently for plastic packaging. So I've broken their guidelines into 4 buckets. Sourcing, where they completely align with the Ellen MacArthur Foundation. It needs to be renewable or needs to be recovered content. Manufacture needs to be clean and not have an externality. And I'll talk about the externality with current plastics, the carbon footprint. It needs to perform beautifully in use, again, with no externality, no harmful side effects. And it needs to do better after use. So those 4 dimensions, I think, are really now what the plastics and plastic packaging industry is using to rethink itself from a circular economy perspective. So let's look at those 4 dimensions. From sourcing, what the plastics are made from, to manufacture, how they're made and the implications, to use, how do the plastic characteristics play into functional packaging, and then after use, how they're recovered. And I think most of you in the room are probably familiar with this type of radar plot where we can plot more than 2 things at once, 4 dimensions. And how well you fill that square sort of grades your product. So I've shown here the ideal world, if you will, and some people smirk at this. In the ideal world, we would completely fill the diamond. We'd have a material that was completely renewably sourced. Going to the right, a material that was manufactured with absolutely no impact whatsoever. A material that, going down, performed perfectly, and by the way, cost nothing in an ideal world. And going to the left, a material that was completely recovered. Now, it's an ambition, I know, but I think sometimes it's useful to define the ideal because we can see how well we stack up against it as a plastic packaging industry. So let's grade ourselves, and this is what the plastic packaging industry now is beginning to do, and it can look harsh. So where are we today? In the red triangle, we start to show the incumbent materials today. Essentially, no renewable content, no movement upward. A big externality in how they're manufactured, so they don't do well toward the right. They don't do well toward the left, as you saw from the Ellen MacArthur Foundation. 14% at best are collected. Where they do darned well is going downward. They perform very well, which is why you see that extreme growth curve for plastics, quadrupling by 2050. So the question is, how do we do well with plastics in more than 1 dimension? Can we expand in the other 3 dimensions? And this is where the plastics industry and the packaging industry that it supplies is beginning to sort of ask itself, so where do bioplastics fit? How can we use those to expand in the other 3 dimensions? So let's talk about that. Bioplastics is still a relatively nascent technology, and because it's nascent, it's been through some huge sort of shifts in perception and misperception as well already. And broadly, we break things into sort of 3 eras, if you will, of bioplastics, starting back in roughly 10 years each. And if we start back in the 90s, when the word bioplastic was used, it was used almost exclusively to mean something that was biodegradable. And people's brand's interest in bioplastic was almost one-dimensionally about solving a litter issue. If you roll forward sort of 10 years into the 2000s, when we as a culture, as a civilization, got a lot more aware of our impact on global warming and climate change, then an almost 180-degree shift in the interest in bioplastics, not where they went, or could go when we were done with them, but where they came from, the carbon sequestration argument. The fact that they could give you a low carbon footprint. And we had groups like the Carbon Trust in the UK, laudably trying to consumer label with grams of carbon. A little bit confusing at the consumer level, but it showed the emphasis on sort of sequestration and climate change. And where we are now, roll forward to what we call the 3rd era, is I think where the era where bioplastics and plastics are seen as one and the same. Bioplastics simply are plastics with a couple of new dimensions adding to them. Finally, thankfully, performance is key. That's accepted, and it should be. That's what we think should be the key. It has to function well. Bio-based is becoming more of an expectation, but it's really very small scale yet. Biodegradable, compostable, still of value in some certain applications, but only where it's the highest good. Because of the first two eras of bioplastics, what we see is that bioplastics, the industry, the plastics and bioplastics industry, has largely defined itself along two dimensions until now. The dimension of, on the vertical scale, feedstock. Is it renewable, is it non-renewable? On the horizontal scale, is it compostable, non-compostable? And in these four quadrants, we quickly would place conventional plastics, be it the polyolefins, polypropylene, PET, polystyrene, obviously not compostable, not renewable. There is a move, of course, and you saw it from the prior speakers, to move one dimension, to make the same things, bio-based drop-ins, to make them bio-based. Laudable, you heard from Tony say, it's a good first step. Is it enough? We need to think bigger. There's a move as well to go the other dimension, one-dimensional, to use oil-based feedstocks and make compostable plastics. Again, a good move. There's also companies, and my company is an example, moving in both dimensions at once, making materials that are bio-based and can be compostable in the right situation. However, I would say that it's almost unfortunate that the industry has defined itself this way until now, because it's only looked at two of the four dimensions that I've been talking about, where it's from and where it goes. And what's been missed is the other two dimensions. And I think the plastics industry now is beginning to get its head around the fact that it's about all four dimensions, where it comes from, how it's made, how it works, functionality and cost, and where it goes. And so I want to talk about each of those now and show you what's really possible today. So let's talk about sourcing first. And let's start by talking about why it's critical. Let's put some numbers on the table. You've heard the big picture from the prior speakers. Let me put some hard numbers on the table. Today, at least a year ago, 2014, 300 million metric tons of plastic contributed 1% to the global carbon budget. You might think not a huge number, but look where we're going by 2050, quadrupling to 1,200 million metric tons of plastic. And we become 15%. Plastics becomes 15% of the global carbon budget. That's why we have to uncouple from the fossil economy. You've seen this example already. Coca Cola making a nice, laudable move in one dimension. They want to move toward the top of the chart. Go bio-based. 30% today, some strong investment to try and get to 100% bio-based, renewably sourced. As Toby said, it's a good move. Is it enough? We need to think bigger. And I think this is where we like the way the Ellen MacArthur Foundation frames this out. We think of what Coca-Cola is doing as good, but evolutionary in the grand scheme of things, making the same thing from a better resource. And what we as an industry argue is we need revolutionary change, and it's what the MacArthur Foundation calls moonshots. And for those of you that did not grow up in the US, a moonshot is what President Kennedy in 1961 challenged the US and said, we want to get to the moon by the next decade. And I think it was 1968, we did it. I remember as a kid in the UK watching that. What we need is moonshots in plastics. So it's kind of comforting to come from my industry and see independents like the foundation talk about bio-based, renewable on the far right-hand side as becoming mature. And what they're calling for is a moonshot where we go direct from greenhouse gas to the plastics that we take for granted. That can be very abstract, so I want to make it real. I want to give you a couple of examples, moonshot examples, revolutionary change in the bioplastic space. So I give you three companies here, one of which obviously I know well on the far right. Two companies, two small startups on the west coast of the US, New Light Technologies, Mango Materials, making today, at a small scale, but making nonetheless, a plastic, a soft, flexible plastic known as a PHA. It's mostly like the polyolefins in its properties, making it from methane. On the right, the company I work for, NatureWorks, investing with the help of US government funding and state, local funding in doing that same thing, making our plastic, which is a hard, rigid material, from methane. And so I just want to drill into this a little bit, again, using ourselves as a case study, because this is the one I know best. Today, this is how NatureWorks describes itself, and has done so probably for the last 5, even 10 years. It's a company in the business of turning greenhouse gas into products. The company got that from the beginning. How we do that today is sort of a long-winded route, if you will. The company captures carbon from the atmosphere by photosynthesis, growing plants, harvesting the plants, fermenting the sugars, like making beer or wine. We don't make alcohol. We make something called lactic acid. It occurs naturally in the body. We've industrialized that, and we turn that building block into a family of plastics and chemicals. The company, though, has made it abundantly clear that it wants to have a diversified feedstock portfolio, and this is where the greenhouse gas Moonshot fits in. So where the company is today, first-generation sugars. Simple sugars, whether it's from sugar cane, sugar beet in Europe, cassava, for example, a big crop in Thailand, or cornstarch, industrially produced in the US. That's what's used today. A huge developing field is so-called second-generation sugars, made from the other parts of the plant. It's developing. The industry is investing in that, the broad industry. But what we are putting sort of our bet on, if you will, and where we're investing our funds is that Moonshot on the far right. Next generation, where we go direct from methane to lactic acid. We basically are developing bacteria that will digest methane and literally, to put it nicely, excrete lactic acid. Then we would make the identical set of Ingeo plastics that we make today. To make this a little more concrete, these bacteria, known as methanotropes, these are the same things the other two companies I listed up there, the other two bioplastics producers, Newlight and Bang Materials, they're doing the same things, but they're using different bacteria. But these bacteria exist naturally. They exist in soil. There's a natural methane cycle occurring in soil. And they exist in seawater. And just to bring this home to an example many people know well, the Gulf of Mexico disaster in 2010, a lot of fossil oil being leaked into the Gulf. With it came some methane. And the big surprise, nicely captured in a National Geographic article here, was that methane never really spiked in the Gulf because the natural bacteria in the seawater that use it as a food metabolized it, ate it. The population of those bacteria bloomed and then died off. So in a sense, that's what we want to do, is almost a biomimicry example. We want now to pick the right bacteria that will make what we want, lactic acid. And that, we think, will make a step change in cost structure to let us really get an even more cost-effective bioplastic to market. So I've talked a lot about renewable feedstocks. Before I leave the sourcing example, I don't want to leave this without making a critical point in our minds, which is that sustainable packaging from these plastics in a circular economy context means not just renewability, but it means addressing sustainability. Sustainably sourcing whatever you're using for your plastic. And only today, that's only possible today with bioplastics. There's no scheme analogous for oil-based plastics. And a great example of a leading global brand we've worked with is Danone. Danone has used bioplastics in two different end applications. On the far right, they've used bio-PE for their drinkable yogurt brand. And then to replace polystyrene, they've used our plastic for the polystyrene cup. In each case, they've used a third-party certification scheme to assure sustainability from the farm all the way to the finished product. So my point is, those schemes are available. Not yet, and may never be available for the oil industry, but the new plastics coming out are sort of working with those, be it bio-PE, produced by Braskem in South America, or be it our material. So let me switch now to the second dimension, manufacture. And the point here is the implication of manufacturing from renewably sourced materials. And this is the externality I mentioned when I talked about the fact that today's plastics that we take for granted in the packaging industry have an externality that nobody really talks about. And that is that every kilo of plastic made emits 2 to 3 times its own weight of plastic. The manufacturer of PET, for example, emits 3 times or 2 to 2.7 times its own weight of CO2 into the atmosphere. And these are industry figures, figures from Plastics Europe and figures from the US Industry Association. Well established in the industry, seldom talked about. So the implication is that with a renewably sourced plastic like our own, and I've shown you our plastic at the top, I didn't have it readily at hand, bio-PE, bio-PET, but they should be added to the chart, you can get a lower carbon footprint, going after that goal of reducing impact of carbon on the global climate budget. Those numbers can be quite abstract at the consumer level, and I want to show you what we do with those in terms of life cycle analyses. But the other point that is key in manufacture is that manufacture is done with what the MacArthur Foundation calls benign materials. You heard Greenpeace listed this morning, and something else they did a nice job on some years ago now is this pyramid of plastics, where some people have argued the pyramid is upside down, but their preferred material is renewably sourced at the base of the pyramid. Their least preferred, as you heard from the Consumer Goods Forum, is PVC. And so there's a graduation of materials that Greenpeace is going after here from a toxicity, safety point of view. So this is something else important to consider in manufacture. Let's talk briefly about what the plastics industry has to come to grips with yet. Because there's a rush to remake today's plastics bio-based, which is laudable, which is good. But what has to be considered as well is the resource efficiency with which that's being done. And what I'm showing you here is simple chemistry, stoichiometry for the technical people in the room. Let's look at the top, bio-PE. How many kilos of sugar does it take to make a kilo of bio-PE? 3 times its own weight. Bio-PET, which Coke is driving, fast, almost 3 times its own weight in sugar. That matters in economics, and it's something the industry is going to have to come to grips with. So all these plastics have their own chemistry. I've listed where we stand. At the very bottom is the latest sort of renewably sourced plastic on the block, if you will, being produced in Southeast Asia, bio-PBS, which is almost a 1-to-1 correspondence. It's so efficient. Essentially, 1 kilo of sugar makes 1.05 kilos of PBS, a soft, flexible material. So this has to be considered as well. Because you heard clearly from the prior speaker that consumers will not pay more. So either the brand absorbs the extra cost of this, or they don't do it. So let me just show you now how these numbers get used in life cycle analyses. An example we put together working with Starbucks. Some years ago, they were trying to make sourcing decisions, choosing between what was then in use for their clear plastic cup, PET, polypropylene, and they were considering Ingeo. And they had a third party do for them a life cycle analysis of 3 functionally identical cups and lids. And now you see plotted the grams of CO2 being emitted per cup and lid. So this really brings it down to an individual consumer. Who knew? If you drank out of a PET cup, you're putting basically 93 grams of CO2 into the atmosphere just for the manufacture of the cup. Polypropylene, a much lower carbon footprint. The plastic we sell, lower still. This, at the time, some years ago, was the basis for Starbucks basically switching from PET, at that point, just to polypropylene. They made an interim step. So an example of how brands are using this to make their sourcing decisions. A more recent example we've been involved with, you heard me mention Danone, their form-fill seal polystyrene packaging, multi-pack. They had a third party do for them a rigorous LCA compared to polystyrene, and they concluded reduced carbon footprint, 25% and 43% less fossil resources. So let's now talk not about where it comes from or how it's made, but how it works. Because this is what we see as the most neglected conversation in the room, where the industry has really been doing itself a disservice by not addressing better the functionality of its products. So, I talked already about Coca-Cola. I want to give you another Coca-Cola example. Coke, again, is indeed, to Toby's point, thinking bigger. Behind the scenes, they are investing in a Dutch company that we know very well. We actually partnered with them ourselves some years ago, a company called Avantium, to make not PET, but PEF, a different building block, F instead of T, to keep it simple. It would let Coca-Cola move in 2 dimensions, not only renewably sourcing, but better performance, much better barrier properties than PET, and perhaps the ability to turn the bottle industry on its head. Of course, along the way, recyclability would have to be addressed here. Some examples closer to home for me, the plastic we make. This is a package in Sam's Club, huge retailer in North America. The package was made out of rPET, now at the time made out of Ingeo. 20% actual weight reduction due to the lightness and the stiffness of the plastic. So this wasn't about compostability, it was irrelevant in this package. They liked the fact that it was renewable, but what they really liked was the fact that they could down gauge and use the fact that it's a very stiff plastic compared to PET. So again, it's how do you leverage the best properties of the material? Sometimes it will work well, sometimes it won't. Another example, You've heard me talk about Stonyfield from an LCA point of view. Sorry, Danone from an LCA point of view. Stonyfield is owned by Danone, North American-based organic dairy. You can see this is their slide from their CEO some years ago when they replaced polystyrene in yogurt. You can see carbon savings being called out. You can see consumer concerns around chemicals of concern, styrene being called out. But in the middle, you see performance. The brand is going after performance. A stronger package, less breakage, better lid adherence. They say they lose less packages in shipping. And what they're saying is they're not paying more for this package. So it's about finding the right functional fit for the material. So let me just wrap up with some more concrete examples for you in flexible packaging. Again, the material I know best here. Here's some examples where not the product, but the wrap, the shrink wrap around the product is being used. So being used absolutely not because it's compostable, that's irrelevant. Not really because it's bio-based, but because it has excellent shrinkage characteristics. It can shrink to match complex shapes without crushing the shape. Again, it's playing to the functionality of the material. More recently, an Italian manufacturer we've been working with has been addressing barrier properties with bio-based films. And for the packaging folks in the room, it's probably a well-known chart. We plot the two critical things: oxygen barrier, water barrier. Where you want to be, bottom left. Typically, a bioplastic like PLA is very breathable, doesn't bring with it inherent barrier. PET, by contrast, a little bit better, but typically metallicized to get good barrier in both dimensions. Polypropylene, biaxially oriented polypropylene, coated with all kinds of different things to move around that space, depending on whether you want barrier to oxygen, barrier to water. What this company, Metavuto, has done has developed an Ingeo-based film using our plastic, which gives you pretty darn high barrier in both dimensions. This can be a bit abstract if you're not in the packaging field, so let me make it specific. What does it mean? It means that a current structure, a typical structure may be a tri-layer like this, paper on the outside because consumers like paper, it prints well, it's stiff, aluminum used to be an absolute barrier in the middle layer, or it could be metallicized PET, for example, and then a low melting polymer, polyethylene, used on the inside because this pouch would have to be sealed together to close it. So what the Metavuto innovation they've now commercialized does is goes to packaging simplification. They take two layers, the barrier layer and the PE layer that was used to heat seal, and then replace it with one layer, their technology, which gives you barrier plus sealability. So you've gone from 3 layers to 2, packaging simplification. Now, to Ignacio's point, it's not enough simply to do things sort of more resource efficiently. It's not enough to just take the linear take, make, waste model and waste less. We've got to go circular. What's exciting about this structure is, at least in Italy, it has been tested, the structure on the right, for recyclability and pulpability. And it can be recycled with paper. So suddenly, the pouch structure that was a bear to recycle because of the complex multilayer, at least in that country, with the paper industry standards there, can be recycled with paper. Another example, a US manufacturer we've been working with, again, aiming at complicated multilayer structures where high barrier is important. What they've done is made a super light web from our plastic, and what they're doing is going after a replacement of what is normally a relatively heavy polyethylene, fossil-based polyethylene layer on the inside of the bag, used to heat seal it. So you can see the numbers, and without even understanding the package, I think you can see the drastic change. 9 micron, very thin, versus 50 to 70 micron, so significantly lower weight. So this is about simple, good old-fashioned cost savings. It's not yet about making the package automatically recyclable, not about making it compostable necessarily. It's going after using the functionality of the material to lightweight a package, which, again, to Toby's point, is it enough? No, but it's a good start. So what I want everyone to walk away from is it's not about bioplastics for bio's sake, it's about them for their functional properties. Use them where they bring you a performance advantage. One last example I want to just highlight, and I don't have a good sense in this part of the world for how big an issue or opportunity this is, but certainly in North America and Europe, this is a huge issue that big global brands are getting hammered with. I show here a snapshot of a web page, Kill the K-Cup. the single-serve coffee capsule, and it's almost about to become sort of the target of campaigning NGOs because it's seen as such a waste. Coffee grounds, encapsulated in fossil plastic, can't compost, very hard to recycle. What do you do? So it's an opportunity that many brands are jumping on. Lavazza, one of the biggest coffee brands in Europe, has taken control of its destiny and designed, with our plastic and some other partners' materials, a compostable cup. What's interesting is a big brand like Nespresso hasn't actually moved in this regard yet, but other brands, other small companies are making what they call Nespresso system compatible, recognizing the opportunity, going after it before Nespresso does itself. So there are many, many other examples like this. There's now a Keurig. Keurig is the big coffee brand in North America in this market, getting hammered, with this Kill the K-Cup campaign. There are people independently making compostable Keurig capsule packaging now. So finally, let me wrap this up, in the interest of staying on time, with the last dimension, after use. How do we take that line, the take, make, waste model, and make it a circle, so to speak? And so again, I'm going to focus, in the interest of time, on one plastic, the one I know best, and just show you as an example what we're looking at. Because here, every plastic is different. And every plastic has to be discussed separately in terms of recycle or recovery. The particular plastic we make, no different. So our attitude is that we want to put a firewall around landfill. Stop things getting in landfill. Look at every option as an alternative to that. I've lost the column headers, but the first column is the incumbent plastics, which can access mechanical recycle or could be used for energy recovery, but really cannot access the middle three. Chemical recycle, compost, or anaerobic digestion. By contrast, we, as a manufacturer, are working to check the box on all five of those. And I want to show you two of those specifically. First, organic diversion from landfill. This is what I readily had at hand. I don't have the Korean statistics, but this is a North American example. What goes in landfill? And I'll call out to you the food scrap, 14.5%, the yard trimmings, lawn and leaf. Together, it's what I call the 28% opportunity, if you add those two together. That is organic going into landfill. In the absence of oxygen, it generates methane. It contributes to climate change. And state after state are setting landfill diversion goals where they want to get organic out of landfill. And a good way to do that is with compostable plastics. So at a typical arena, when you look behind the scenes of what's going on, you see an awful lot of food thrown out. The picture on the bottom right, typically that food is mixed with good old-fashioned, high-performance fossil plastics that do not degrade, and that stream is condemned to landfill. If all of those materials can be now made compostable, and ourselves and a variety of our industry colleagues have performance compostable grades that are making these products, these plates, these cups, the cutlery, then the whole stream can be diverted from landfill. And we, and in fact, our industry colleague BASF, have corporate partnerships with a group called the Green Sports Alliance in North America. Teams and venues that want to divert organic from landfill to execute against this value proposition. So I'll wrap up now with just a quick mention of recycle, because we find the misperceptions here abound with a new-to-the-world material. Most plastics, and indeed bioplastics, which are simply plastics, can be recycled after use. Very few are. Why? It's the business case, the economics compared to low-price fossil feedstocks. But Toby, you made the point that many big brands, global brands, are getting pushed and really having their feet sort of held to the fire. It's not just to big companies. We're a company of 100 people, but we don't get a free pass. We introduce a new-to-the-world plastic, and we are taking care of how it gets introduced and addressing recycle as we go. We don't have the luxury that the PET or polyolefin producers had 50 years ago to just launch it, create 300 million tons a year, and then think about recycling it. So we're doing it as we go. And we could talk in more detail offline here what we're doing, but we're working collection schemes. I came from Taiwan Monday, where I was sitting down with the leading Taiwanese recycler who's collecting PLA bales. We have an interest in those ourselves because we have valid end markets for those. So we're setting specification for the post-consumer material. We're working to show how to clean it up and setting flake specification. And we're developing end markets because we have interested customers that use virgin and would obviously love recycled content. So I'll pause there. My point is simply for an awareness point of view that you know that this is being addressed. And I'll wrap it up. And so, again, a huge thank you to the organizers for the opportunity to address how we're rethinking plastics packaging along these 4 dimensions. I hope I've made it clear that there's, I think, and I hope my passion and excitement comes through, fantastic opportunity to move in all 4 of these dimensions at once. So I thank you, and I'll be around for questions the rest of the day, and look forward to the panel discussion with, this afternoon. Thank you.